So, what's going on? How's everything going there? Everything all right? What's going on here? Why isn't that letting me? There we go. You're good. Thanks, Megan. That's great. Um, I'm recording now, so I hope you guys doing well. What are we now? Week 9? No, week 8. So I sent an announcement out there last night. Everything is peachy. Yeah, great, Jade. I'm glad. Um, the we got quiz 2, which is coming out there this afternoon. That'll be open there for a week. Okay, and it's not bad. It covers the whole point of the quiz is to kind of give you a vision of what test 2 is. We've actually done quite a lot since our last test, and I'll go over a bit of that there today. But the quiz will be open there for a week. It's kind of an assignment. And I'm actually thinking that the test will be 2 parts again. And I want to give you guys some time because the test is, it's a good one. I think in there's multiple choice, there's true or false, there's matching, and like there'll be what's the word I'm looking for? An electronic component, so online, and then there will be a paper base that I was thinking there I might give you a week. I'll give you at least one day, maybe 48 hours to do, but that's for your test there next week. So I'm still trying to work out the fine details, but for your test there, you'll have lots of time. There'll be an online component. There'll be a paper base that you'll just take pictures and upload. But other than that, I think we're all right. How is everything there on your side there? I hope all is well. What was it? The case studies there, I should have marked there by the weekend. I'm already kind of on them. And I hope all is well. I don't know. It's 8 o'clock in the morning. It's just been a rough week, and I don't know if there's a bug going around. Well, welcome to COVID. I guess there's lots of bugs going around. But yeah, if you guys got nothing, I got nothing. Let's go. So, where are we here? So, what I want to make clear there today is this is where we are, measures of deviation. Here, like what we've been talking about there, well, for the past million years has been mean, median, mode, right? And like these are what we call these measures of central tendency. Where is all the data around, right? Like if your data is all in a nice bunch around one number, well, then that kind of tells you there that, you know what I mean, that number is key to everyone's thinking. Why is everyone around this certain number, the mean, right? And but if your data is all spread out like this, you know, now you've got different ideologies, different people are thinking different things. So that's where we're headed now. And we've kind of taught you guys well, you guys have taught yourselves. You know what I mean? I'm just a dude on a screen. You know what I mean? You guys are doing this, and proud of you guys. Where we're headed now is I think I sent the announcement out there that we've got quiz 2 there this week, test 2 next week. We've got the assignment 2 will be released the week after. Week 11 is kind of an off week. And then week 12 and 13, we're right into, like the assignment 2 is due, quiz 3 will go out, and test 3. So there's a lot going on, and I don't really want to add to your troubles, but this is kind of the direction that we're in. And again, I don't think that I don't want this course there to be the issue. There are some tricky things there today. They're not bad at all, just following step by steps, and that's where we're at. So this is what we're covering there today, measures of deviation. Okay, how spread is the data, because that's where the last third of the course is going to be. And I'm kind of introducing some of the stuff there at the end, you'll see. And it'll be on the quiz, it'll be on the test there, but it's not bad. Okay? But in order to do these in 3.2, these pages right here, like, you don't have to read these. There's one page 85, one page 87, and one page 88 that I'll talk about there today. You don't need to go back and read them. It's only 3 pages. You know what? It doesn't hurt to go back and read them. But you don't have to. Everything's covered there in the PowerPoint. And in order to get to here, there's just a couple concepts there that I'll have to show you, but it's not bad at all. So if you guys are good, I'm good. And the whole purpose here is to compare different samples, because ultimately the whole goal of this is because in theory you cannot compare apples and oranges. You can't do it. Okay, yeah, they're fruit, but an apple's an apple's an orange. An orange, you can't compare one against the other. Well, you know what? We can. We just got to play with things a little bit. And that's where we're headed there today. Okay, well, not today, by the end of the course. So, just a little, this is completely off topic, but not really. I wanted to say this there as the quiz is going out, and we've got assignment 2 coming out and all these kinds of things. I just want you guys just to be careful with rounding, okay? Like if you look at this one right here, 8.453 is equal to 8.453. It's not equal to 8.5. We round numbers for ease of use, okay? I don't want you guys to do that, okay, as some of you guys have been doing. And I want to kind of point you guys in the right direction here, because I'm going to be looking for this for the quiz and the test and these kinds of things. And there's a potential here to make a kind of a serious error if the rounding is too severe. And I just want you guys there to be careful, because this is where we're going here. And I'm just going to show you guys a little bit of where we're going. You're going to be, you won't have to make the table, but you're going to be doing some calculations here that may involve decimals and these kinds of things. I just don't want you guys to, if a number is 6.6, that's what the calculator spits out, is 6.6. I don't want you guys to automatically just write 7. Okay? I don't mind decimals. And generally the rule of thumb when it comes to decimals and calculations, even in your chemistry that you guys are doing, you guys have already done, your math component of the chemistry was the first half. But kind of carry all of your numbers in your calculator, or at least 2 or 3 decimals, and carry them through all the way to the end, and only round at the end. Okay? So, you just have a look here. And I just want to show you guys there that I've got, 1, 2, 3, 4, 5, I got 6 numbers here. Okay? And if I don't round them, I just take the numbers as they are, and I figure out the mean. Okay, it's 78.76. Okay, that's the mean. So, you know what I mean, somewhere 79, this and that. Okay, but if I round these numbers right here and now to 73, 76, 75, 87, 81, and 83, I get a mean of 79.6. So you see they are different. Like this is off by what? About half, maybe 0.5. There's a difference here in and around there. Statistically, it's not too bad. Okay, but I'm just saying where we're going, and you guys will see there at the end where we're going to when we get into standard deviation, variance, these kinds of things. Just be careful you're rounding. Okay, you know what I mean? Carry 2 decimals through, carry them through, and then if need be at the end, round them. But I don't mind a couple of decimals. Okay, I just don't want the rounding to be too severe that it augments your answer. Like right here, this isn't too bad, okay? But some answers there, if you round too far, you know what I mean, you could your end result could be wrong. So just be careful on that. Any issues there, email me up. What we're gonna, I'm gonna have to go back a little bit in order to go forward, and but it's all good. So measures of position and range here. We're going to talk about these two things right here, there today, and then we're going to get into these things right here. I know it looks like a lot, but it won't be. I think the PowerPoint's only 20 some odd slides. So here are two sets of data. And you're going to see these again. I just kind of pulled these there from slide number 19 or something like that. They're just two, because you'll see this again. So if you just look at these two sets of data, okay, this one here goes from 40 to 60, all right? This one here goes from 0 to 100, okay, so they do look different, a lot different. But we've calculated here that the mean and median for A data set is actually 50, and for data set B, the mean and median is also 50. So looking at this, first crack at the can here, wow, these two data sets are pretty similar. But now let's look at the range. And the range, you take for all of these data sets, just a little hint, put them from lowest to highest. If it's not already done for you, make sure you do it, because that's all about the median. But we'll get in there, and there'll be a little bit more things there. So you rank these there from lowest to highest, okay? You take your highest number minus your lowest number, and that's your range. And you think about that. Your range is your range of numbers. We'll take your highest and your lowest, subtract one from the other, and that will give you the range. So you see here, both these guys there, the mean and median are about 50, so you really can't compare anything there. They're both the same. And then the range here for data set A is 60 minus 40. So the range is 20, which, you know what I mean, all the ideas are around a central theme. So in the data set A, the mean and median is 50, and the range is 20, so it's 10 on this side, 10 on this side. So this data set A is pretty compact, which is statistically significant. You look at data set B, it still has a mean and median of 50, but its range is 100. So it's 50 on this side, 50 on this side. The data is more spread out. Again, statistically significant, but why? And these are the questions there that we want to answer in statistics. Societal questions on why actions happen. Okay? So there's the range. The mid-range, you'll remember, is calculating the range and then dividing by 2. Okay? I think that was back in week 5 or something. Once the data, and you see, here's your data set here again, the same one there we just saw. Okay? And once it's been ranked, once it's been ordered, from lowest to highest, I just wanted to, if you guys are just joining in, don't worry, we haven't missed any, you haven't really missed too much, where we've just done slide number 3 there. Oh, isn't that sweet? My wife's just going to work, and my kids are in their pajamas outside on the streets. Wonderful. Okay. All right. I hope they're fine. Anyway, what we've got here now, we're introducing something called a percentile. Is it anything crazy? No. We deal with it all the time there in when you're talking about child growth. You can go right on to Google. You can Google boys, girls growth chart. Okay, and you can see 25%, 50%, 75%. Hey, you guys! I'm teaching a class. Love you guys. Bye. Oh dear. Oh, you wouldn't believe what had happened last week. Oh, it's just in my PSW course. It's just mayhem. But I'm sure you guys are all going through the same things. It's just you guys are on mute, so I can't hear your children. That's okay. We're just getting by here, and I hope you guys are doing well. To go back here, percentiles is all just about finding, where the data is. And if you if you Google that, you go to I use it there with my kids. You've got the boys and girls growth charts from. There's one there. There's a famous PDF there. It goes from 0 to 2 years, and then I think it's 2 years to 22 or something like this. And you can actually see all the different percentiles of growth of children across Canada, and they've compiled it into, so you can compare where your child is within there. Okay, and what we're talking about here, a percentile is just a fancy word for percentage. Okay, and you've got quartiles. They come from the word quarter, which just means 25%. Okay, so you've got the first quartile, or Q1, which is 25%. Q2, which is the second quartile, is also known as the median. 50%, right? It's middle of the data. All the data has been ranked, lowest to highest. And you have the third quartile, which represents the 75%. Okay, but we'll get into that. And I put these in here. Just that data there you just saw, it's been ranked lowest to highest. And we can break up the data into, quarters, basically. Right? And so something like this. This is where we're at. And being able to break these up, it's not that bad at all. And we just use this formula here. And where K is K is the percentage. So the whole idea is identifying percentiles in a data set. So I could ask you to find the 10th percent. What number represents the 10th percent? What number represents the 50th percent? What number represents the 75%? Any percent you want there between 1 and 99, we're good to go. And how do you do it? It's not too bad. Location of the percent, which is K, location of K, is equal to the percent divided by 100. So that just gives you a decimal. So 75% divided by 100. So this will be a decimal, 0.75. times the number of data points you have plus 1. So in this case here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This right here would be 10 plus 1, so that'd be 11. And it works. It's pretty easy peasy, and we'll show you more here. Here's an example here. Find the location of 10% of the data. And how we write this is P10, which just means the 10th percentile. Could be P25, could be P37. Find the 37th percentile. Doesn't matter. It's all the same math. So just to let you know there, if the location of the percent is a whole number or is close to it by 0.1, take it. And in this case here, you just got to do a little mini-mean. But you see here, here we have a data set, 60, 60, 62, all this right here. Okay, it's all been ranked. It's all from lowest to highest. And we want to find P10. So let's go. And what they've done here is they've just changed LK. And here we're looking for P10, so it's P10. No difference here, okay? This is the 10th percentile, which is right in here. So what do we have here? The 10th percentile, okay? So 10, because it's 10%, divided by 100, okay? Times, we have 12 numbers plus 1. That's all it is. Not too bad at all. So and what we get here is P10 is equal to 10 divided by 100 times 13. My answer here is 1.3. Okay, so now what are we doing here? We have 1.3. All right, so that is not, we didn't get a simple whole number here. We got a decimal. And you see, if it was 1.1, I would take it. Okay, if it was 1.9, I would jump up to the next number. But because it falls in between, you'll see here, if LK is a decimal between 0.1 and 0.9, you take the mini mean of those two numbers. Okay, so you see it's 1.3, so that means I take, this is 1, so this is in here. So I take these two numbers here because it's 1.3, we go down. Okay, 60 plus 60 divided by 2, so my the 10%, okay, falls below 60. This is how that one goes. Here's another example here. If LK is 12.4, whatever that is, okay, you take the average of the 12th and 13th data value in the array there. So just have some fun with this. It's not too bad. You just plug and play. So this will be on the quiz. It'll be on the test there. I'll simply ask you to find, I'll give you some data. It may be organized. It may be disorganized. So the first thing there y'all have to do is just put it from lowest to highest, right? And then whatever amount, let's say I ask you to find P25, right? So P25 is equal to 25 divided by 100 times N, which is all of the number of data points, plus 1 is equal to whatever this is, and then there you go. So you see there that the 10th, approximately 10% of the data falls below 60. We'll get into more of these kinds of things, but yeah, that shouldn't be too bad. And here are just some examples. Here I've got, I think it's the same data set, right? 60, 60, 62, 60, 60, 60. Yeah, it's the same data set here. And I've just P10, P25, P67, P90. So these are just asking you to find the percentages, 10%, 25%, 67%, 90%. And you all can try these out. I circled this one here because P25 is actually Q1. Quarter 1. So you might see me refer it as Q1 or Q2, Q3. Q1 just means 25%, P25. Q2 is P50, which is just the median. Q3, which is 75%, could be P75, these kinds of things. So have a look at these. I don't think they're that bad. Any issues, let me know. Okay? That's to find percentile. Find the range of the following data set. Well, you find your highest and lowest. So in this case here, your range would be 13.2. Not too bad. Calculate the first and third quartile. Okay, so the first quartile, okay, Q1, 25%. Okay. And I've quickly done this here. If you guys have any issues, just let me know and I can break this all down. Your third quartile, which is Q3. Strange little terminology there, but I don't think it's too bad. Okay. Let me know how those go. And you'll see here that you'll remember up here that there's a couple things here that we need to know in order to do these. Again, you don't have to read these if you don't want to, okay? Everything is self-contained in the PowerPoint here. And these things here we'll need to do here, but they're not bad at all. So what do we got here? So where we're going to go is we're going to talk about something called MAD. Am I going to test you on it? No. Let me be clear on that. We're going to go over this, MAD, which is mean absolute deviation. Am I going to test you on it? No. But do you need to be able to do it? To do variance and standard deviation? Yeah. And I'll show you here. It's not bad. Okay. So what do we got? What is going on downstairs, man? Those kids. So Again, same data set here that we've seen there before. Okay. And I want to have a look here. So we're given two sets of data. It is possible that the sets have the same measure of central and even similar ranges. Like, look at this one here. It's not the same data set, but we'll have a look here. Here we've got mean and median. They're both the same for data set A and data set B. So I really can't compare anything here because they both look like they're identical according to the mean and the median. Well, look at the range. Well, even the range is 90. So that's not giving me any information. All right? So the summary statistics seem to imply that the data sets are identical. Sorry, I'm reading right here. However, we know that it's not correct. And A seems to be more clustered, while B tends to be more spread out. It's all about distinguishing. It's all about comparing apples and oranges, right? So, you know what I mean? You guys can read all this. It's called the measure of the deviation. Here we're talking about the spread of the data. I'm not going to ask you anything on deviation of the mean because it's not. It's just one leg. Like I don't. When I look at a chair, I don't see the four legs as, you know. I only see the chair. I have no idea if that made any sense. It probably didn't, but it's all right. I don't want you guys to worry about this. What we're going to be doing, though, you'll see, we'll get there. So, calculating the deviation of the mean. Now, here we're talking about the spread. So here I've got a 5-set data set right here. So if I find the mean, okay, which we can all do, you add them all up divided by the number of data points, right? And here I got a mean of 68. Okay. In order to do these, first thing you got to do is you got to find the mean. And so the mean is your central, right? Right? That's your mean. And now what we're going to do is all the data points, we're going to measure how far they are from the mean. So if you have a cluster of data points right here all around your mean, well then all of your points should be pretty close to the mean, right? So your number should be kind of small. But if you have data points that are so far away, you're going to have more spread out. And we'll show you this right here. So we found there that the mean is 68. So it's right in here. And the deviation of the first data point, which is 55, right? So what we do is we take the number 55 minus the mean, and we get negative 13. And so what we've done here is we've got our 5 data points right here. And what we do is we subtract that data point from its mean, because I want to find out how far away it is from the mean, because the mean's right here. So here I've got negative 13, here I've got negative 3. So negatives are okay. You're going to get negatives. That just means that it's on the south side of the mean, or the lower end of the mean. That's all it means. A positive number will mean that it's on the plus side, the other side of the mean. And the number difference is what we're interested in. So you look at this one right here. Your data point that's farthest away from the mean is 55 because it's 13 units away. And you'll see what we've got here now is we have a spatial. We've determined each data point and its distance from the mean. And it's just interesting to note there. Again, let's go over this. There's your data point subtracted from the mean. And you'll see there the mean is the same for all of them, of course. So 55 minus 68 is negative 13. 65 minus 68 is negative 3. 70 minus 68 is 2. 72 minus 68 is 4. 78 minus 68 is 10. Interesting to note, okay, if we add them all up, they go to 0. Okay? Which we're gonna add an extra column here, and I'll show you this. So the sum of all the deviations from the mean will add up to 0. That's one of the testers that you know that you've done it right. If you add this column all up, and if it goes to 0, you're good to go. We'll show you this here. So, to continue on this notion of measuring a data point's distance from the mean, now we'll take the absolute value because we're going to eliminate that negative. And all that means is, instead of there being negatives here, they're just going to be, you're going to get rid of the negatives. Okay? So whenever you see a straight line bars here, these are brackets, but they mean absolute value. So here, I'm not, remember we were just talking about there, the -13, the -3. We're not worried about negatives and positives here. We're just worried about distance. So if something is -13 distance away from the mean, as opposed to something being +13 distance away from the mean, the distance is the same. So let's have a look here. And you'll see here that we've added another column to our data set. So same data set, same mean. We just did this one here. We subtracted one from the other and we got these guys here. If you add all these guys up, they will go to 0 every time. Okay? And now we've got this column. We've added an extra column, which is the same as this one, but it's absolute. So any negatives in here, they automatically become positive. And that's what we've done. -13 becomes 13. -3 becomes 3. 2, 4, 10, they don't change because they're already positive. And now we add this column. See, this column here will go to 0, but now we've changed it to absolute value, so it's only positive. So we add all these numbers together, and we get an answer of 32. Okay? And this is where we're going here. And the mean absolute deviation, okay? So you find the mean of this here, and we get 32 divided by 5, we get 6.4. Now, I'm not really going to go into any details just yet about what these numbers are talking about, but generally, the bigger the number here, the more spread out data becomes. And this one right here, which tells us the average distance between a data point. Okay, so this is what this number here is telling us how spread out the data is. If we get a bigger number, generally we want a smaller number. Okay. Okay, so I've given you a bit of background. Am I going to test you on any of these, like MAD and all these? No. But in order to do where we're going, you're going to have to make these 4 columns. Are they difficult? No. There's your data set. You calculate your mean. Okay. Subtract one from the other. And please know that it's your mean from this value. So it's 55, take away 68. Gives you a negative. And that all negatives will become positive and you add them all up. That's where we're going right now. Here we go. Welcome to it. Everything we've been doing so far is about this moment right here. Okay. We're going to get into something called the variance. Okay. And again, this is all about the spread of data. And ultimately, the variance will give us to the golden goose here, standard deviation. Okay. The variance is the mean of the squared deviation from each data point. Okay. Basically, what we're doing here is we're doing the same thing. We're just going to add an extra column. That's all we're doing. The squaring. Now, why do we square this information? Okay. Because what it does is we get rid of negatives. We get rid of all this funny stuff. Okay. And that's what we want to do. Let's just get into it here. The variance of the population there is the mean of the squared deviation from each data value to the mean. Horrible definition. But all we're looking about here is we're going to take this information here, we're going to square it, and we're going to utilize it to talk about the spread. And the bigger the number, the bigger the spread. Here's the formula there for variance of a population. We're not going to use that one. Okay, and it's just they use the the variance squared is equal to the sum of x minus the mean squared divided by n. We're not going to use this formula. Okay, so no user. We're not going to use population. We're going to use sample variance, and this is the variance as a sample is represented by the symbol s squared. Okay, is equal to sum of x minus the mean squared, all divided by n minus 1. I'll show you how to use it. It's not too bad. And again, your quiz, your test, if you joined in late there, your quiz will open up there this afternoon. Y'all have a week. It's paper-based. You guys can take pictures and upload it, these kinds of things. Your test next week, there'll be true and false, multiple choice. I even think there's some matching. It's quite a long one. And what I'm thinking about doing, I'm not 100% yet, but I want to give you guys somewhere between, I don't know, 48 hours and a week to do it. Kind of like a take-home test. And we'll see how it all goes. I'll give you guys an update there towards the end of the week. Okay, but you guys will have lots of time there to do these. So this formula here, again, you don't have to memorize it there for your test and quiz. You just have to have it available. Okay, so just a note, you will never use this formula for my course. Variance, though, you'll need it there for the quiz. You'll need it there for the test. Okay, this is the formula there that you're going to use. And you see, what we're doing here is you're going to be squaring. And I'll show you this right here. It's not too bad. So what we've got here now, calculate the variance of the sample set. So it's the same sample set here. So there's your data set values. We've calculated the mean. Okay. And now we subtract one from the other, and here we get negative 13. You remember there before we just took the absolute value? Well, we're not going to do that. We're just going to square it. That's all this is. So the only difference between this column here and this column here is I just take this number and square it. So negative 13 times negative 13, you punch it into your calculator, it comes out positive 169. And it's the same as positive 13 times positive 13 will also give you this number. And you see the whole point of this column is just to get rid of the negatives. That's all we're doing. Instead of doing absolute value, we're just squaring it. Okay? So subtract one from the other, your mean from your data set, you get a value. Square it. So negative 13, okay, so that's 169. Negative 3 is positive 169. Negative 3 squared is positive 9. 2 squared is 4. 4 squared is 16. 10 squared is 10. So in this column here, there shouldn't be any negatives. And remember, this column here, if you add them all up, goes to 0. That's your self-check. Halfway through this table, and this table is going to get bigger, by the way. So please be careful of rounding, because you'll see here, you're going to have 5 or 6 columns here, where you're going to be one number here, punch it into here, here, here. And if you're rounding right here, that means that there's the potential for error on. So just be careful of your rounding, okay? So what we've done now is we squared all these values, okay? And then you sum them up. Add them all up. So 169, 9, 4, 16, 100 adds up to 298. So 298 in this particular case means all of this. Okay, so here's your formula there for variance. The sum of x minus the mean all squared divided by n minus 1. So this number here just goes right in there. Okay, and then n minus 1 is just 5. You have 5 data points, 5 minus 1, which is 4. And the number that spits out, 74.5. I'm not going to go into crazy detail, but it's pretty spread out. And I'll get into more detail. Where I'm at there for this stuff, it's more on producing numbers. We'll get the last half of the course, which is crazy. I can't believe it's already week 8 already. But the last quarter or last third of the course will deal with this whole concept further. So we'll get more into the ideology, the theory, the philosophy of this. More for this test here, I'm just looking for your ability there to punch out a number for these type of questions. So again, just to recap, there's my numbers, there's my mean, subtract one from the other. You may get negatives, it's all good because we square these numbers to eliminate all the negatives, and then we add them all up. This number here goes right in there. Number of data points minus 1, and we get this number. And this is your variance. Now, this is an important indicator of the spread of data. Okay, but it's not as important as standard deviation. Standard deviation is the big banana when it comes to talking about spread. Well, then why, Ian, did you just teach us the variance? Okay, because the variance is the, you just take there's your formula for variance. Okay, s squared is equal to the sum of all this squared divided by n minus 1. Have a look at your standard deviation formula. It's just the square root of that whole thing. That's all it is. So you find your variance, and then you take the square root. Okay? So you look at this one right here. We did all this work here. We sub this in, 5 minus 1, we got a number of 74.5. This is our variance. This is good in some statistical circles. If you can take it one step further, you take the square root of your variance, which is the same formula, but just square rooted. Okay, so you take the square root of 74.5, whatever that is, and that is what you call your standard deviation. So the two formulas are absolutely related. You cannot find the standard deviation unless you have found the variance. Okay, because the variance, okay, you square root that, and that's how you get your standard deviation. There's lots of questions here. We'll show you guys this. And the standard deviation, okay, again, we're talking about the spread. And the smaller the standard deviation, you see how it's going to be more compact. The larger the standard deviation, or the larger the variance, okay, it's going to be more spread out. And you know what I mean? It all depends on how it all works. Okay, so the standard deviation is the most common statistical measure of dispersion. Okay, where the data points are located, and is calculated by taking the square root of the variance. Okay, good. See, we're almost done. Kind of. So what you have here now, calculate and compare. That's what I like. All right, because you're going to be comparing two sets of data sets. Okay, so calculate and compare the sample standard deviation of the two data sets to determine which set has a greater dispersion. Which data set is more spread out? And you'll see what we've done here. Okay, we calculate the mean. Calculate the mean. They both have 55. Because the mean is the easiest, and the mean tells us a lot of information, but you really can't do anything else without the mean. And then you see these ones here. I'm not going to ask you guys to do this. This is a bit of a smackdown. You know what I mean? I'll give you guys somewhere 6 or 7 data points or something like that. Okay? But you have a look here. Just to break it down, there are the data sets right here. There's A and B. Okay? And here's A. And you remember, it's first thing you got to do, put it in order, lowest to highest. Find your mean, okay? And the mean is 55. They're missing the column here, but 10 minus 55 is negative 45. 33 minus 55 is negative 22. Blah, 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 blah. So, just a little bit of advice. You will be doing this. Not as big, but you know what I mean. Please be careful. There's huge opportunity for error here, because look at all the numbers you're doing. Look at all the calculations you're doing. You know, you would have a mean column here. So 10 minus 55 is negative 45. Hey, every time your fingers touch the calculator, there's potential for error. And I don't want that. Okay? So this is where rounding, just be careful. Don't really round. You know, don't round too crazily. You know, if a number is 6.5, keep it as 6.5. You know, don't round it up to 7 or 6, because then the errors will continue and kind of manifest themselves, right? So you take your 10 minus 55, you get negative 45. And you get all these numbers here. And if you add all these numbers up, what do you get? 0, right? That's your kind of self-check. And then you take these values and you square them. All right? And you get all these numbers here. Sorry, I just heard my dog. I'm just trying to, I don't know what's going on. And so you take all these numbers, you square them, and you add them up. And you're going to get, you just might get an outrageous number. And what do I mean by outrageous? Like, you're adding 2,025 to 484 plus 441 plus 400 plus 9 plus 4 plus 1 plus 0 plus 1 plus, you know what I mean? These are numbers, these are kind of nonsensical. And you're adding them all up. And you're going to get a number, 6,728. Well, it doesn't mean anything to me. It's okay. It's all right. And what we've done here is you take this data set here, you find this one out. So this is the variance of this one. This is the variance of this data set. Okay? And then you take the square root. You take the square root, and these are the numbers you get. So now, I just want to go back and compare. So this is data set A. Okay, they both had a mean of 55. They both had a variance of 90, a range of 90. So this one here spit out a number, a standard deviation of 21.92. The other data set spit out a number of 25.70. In a nutshell, I'm not going to ask you guys to analyze these yet. Next, for test 3, I will ask you guys to start analyzing standard deviation. But I'd be so happy if y'all could just, for the quiz and the test, be able to spit these numbers out. That's what I'm looking for. The mean, median, mode, the stuff we've kind of been covering there ever since like week 4 or 5. This kind of stuff I'm going to ask you to interpret and analyze and that kind of stuff. But for any type of standard deviation, I'm only showing it to you there this week, and what I'm going to test you on it crazy next week. I am going to test you on it, but just on your ability to spit out these numbers. Okay? For test 3, I will ask you to analyze what you're spitting out. Okay, as far as these guys go. So, but anyway, data set A, data set B. You'll see here we've got a smaller number. What does a smaller number mean when we're talking about standard deviation? A more collected view of data points. It's not spread out. The bigger the number, the more spread out the data points are about the mean. That's all we're talking about here. Fairly exciting, isn't it? So there's your MAD again. And if you guys joined in late, I'm not going to test you on the MAD stuff. I'm only testing you guys on variance and standard deviation as far as this stuff goes here. The range, being able to calculate these, that's what I'm going for. But you'll see there that if you joined in late, I've added a couple of pages here from 3.1. You don't need to read them. You don't need to do anything. Everything is in the PowerPoint here. In order to do this stuff today, you got to have a look at this stuff here. And I've included it, but I'm not testing you guys. This one here is good. This formula here, oh yeah, that one's good. You better know that one. Okay. Same thing there. But the MAD, anything to do with that? No. I'm not testing you guys on that at all. Okay? But you have to do this to get to the variance anyway, so I guess I kind of am. Where are we here? Good. So, not really going to go into the MAD. It's a part of the variance. It's a part of the standard deviation, but I'm not going to test you on any of its theory or relevancy. Okay? It is a column in the variance standard deviation right here. Okay? But I'm not going to be testing you on it per se as far as theory goes. Here's one here. It's called the range rule of thumb. Just another silly little formula. And it's not 100%, but it is approximate. And where we're going, this is kind of a rough approximation. Okay? That's all this is. The range is 4 standard deviations. Or the standard deviation is about 1/4 of the range. So here is your range. Sorry, I'm kind of going in the camera. This is your range of data, whether it's from 1 to 100 or 10 to 90 or whatever it is. Okay? Now, standard deviations are basically percentiles. They break this data up. And I want to show you guys something here, why we rank it from lowest to highest. Well, look at these curves here. Like, this is your mean. And let's say this is the number of bananas eaten by children under 6 from, I don't know, man, whatever. Okay, number of bananas eaten. All right. So here we've got a mean. Let's say, I don't know, 3 bananas eaten, okay, is generally what people are eating. Well, these guys here are eating under 3 bananas a day. These people here are eating more than 3 bananas a day. So that's why we rank our data from lowest to highest. First thing you do, always, when you're dealing with these kinds of things. Because down here, these people here are eating like 0.6 bananas. And these people up here are eating like 7 bananas a day. So it's from lowest to highest. Okay? I'm just trying to find my spot here. So when we get to the range is all your data sets from lowest to highest, okay? And these deviations, they break the data up. 25%, 50%, 75%, 100. So this little formula here is called the range rule of thumb, where the range is equal to 4 standard deviations. All right? And to approximate the minimum and maximum values of a typical data in a set, we got the minimum value is equal to the mean minus 2 times the standard deviation. I'll show you guys right here. We have an example. And did I keep the animation here? Let's have a look. No, I didn't. I removed the animation. That's right, because it wasn't working. Have a look at this one right here. Quick, easy peasy little question. The average hourly wage for a registered nurse is $36.79 an hour. So that's the average wage. That's your mean. And it has a standard deviation of $3.46. Use this information, find the minimum and maximum wages for nurses. So you got to think here. What did I give you? I gave you the mean, $36.79. I gave you the standard deviation, okay, which is 3.46, right? So, what we've got here now, this is your whole data set. Here is your mean, okay, which is 36.9. standard deviation. Okay? Now, what can we do using this? We've got the range is equal to 4 times the standard deviation. Now, if this is your mean here, how do we figure out the range? Because I've only given you, now remember, I'm going to kind of jump back here. Where are those? This right here. If you have a look here, this is your data set. Your range is this whole value from lowest to highest. The standard deviations break it up into pieces. So I need to figure out my range. So my range is equal to 4 times the standard deviation. Well, range is equal to 4 times $3.46, which was given. Nothing crazy there. So my range is equal to 4 times the standard deviation. So my range is $13.84. So that's what this one right here is. There's your range, $13.84. So there's my lowest value. There's my highest value. There's my mean. All right. So let's have a look here. If my range is 13.84, so that means that half is going to be on this side, half is going to be on this side. So what's half of 13.84? 6.92. What's half of 13.0? 6.92. And you see you've got a negative side and a positive side. So the mean minus 6.92 gives you a lower value of 29.87. The mean plus the higher value gives you 43.71. So these are your two highest values. So basically what they're saying there, the average hourly wage for a registered nurse is $36.79 an hour. So that's the average wage. Standard deviation is 346, 346. Those are your standard deviations. So now find us the highest and lowest values on the extreme. So nurses in this particular situation get paid anywhere from $29.87 an hour all the way up to $43.71 an hour. Have a look at that one. That one's a good one. You will see something like that. Okay. Your range rule of thumb. Okay. It's quick. It's easy. Is it accurate? To some degree. Okay. So this one here, quick, easy peasy, gives you an estimate on the range. If I only give you the mean and the standard deviation, now you have a way of figuring out your range. That's what this formula is. It's a way to figure out the range from the standard deviation or vice versa. Okay. Now we're going to get into something called the empirical rule. And this is where we're going to hang out there for the rest of the semester. Okay. Everything we've done there ever since week 1, we've kind of atomized things and kind of broken everything up. Now we're into the end game as far as that goes. The empirical rule. And what we're talking about here, we're talking about a normal distribution. And like if we can just go back to the number of bananas eaten, you know what I mean? And if this is, what do we say, the mean, okay, of the number of bananas eaten is 3. That's the most people are eating 3. All right. And then, you know, they deviate off. But you have a look here. There's your mean. And there is standard deviation number 1. And you'll see here that 34% of the data falls between a positive standard deviation 1. 34% of the data falls on the negative side, the reciprocal side. So within the first standard deviation, you have 68% of the data. Between the second standard deviation, you'll see here, and you see right here, 68. And then you'll see here, standard deviation number 2. It's just a line drawn. And what we're talking about here is area under the curve. Because now, when we're dealing with these things called a normal distribution, where they're all going to look like this, okay? And just to show you what's on your quiz there this afternoon, you're going to see something like this. Not too bad. Where did I go now? Sorry. There we go. So this is your first standard. This is your first deviation. One standard deviation above the mean. One standard deviation below the mean. And you'll see there what we're interested in here, because eventually I'm going to get you guys to draw these. And I'm not looking for clean, you know what I mean, make it messy, whatever. I'm just looking for these percentages, areas under the curve. So 34% of the data falls in here, 34% in here. Together, 68% of the data will be within the first standard deviation, positive and negative, about the mean. 95% of all data points will be within the second standard deviation. So you see now we're starting to tail off now. People are starting to eat 4 and 5 bananas. On this side here, people are starting to eat 1.5 bananas. They're going down, right? And you'll see here now we're on the tail ends, okay? 99.7% of all data lies within 3 standard deviations, okay? Good. That's where we're at right now, okay? And it's these percentages here under the curve that we're going to be talking about. The empirical rule allows for a more precise information to be drawn about the distribution of data and the percent of data that falls within certain intervals. However, it only works for distributions that are symmetrical and roughly bell-curved, which we also call normal distribution. Okay? And I really want you guys to see the areas under the curve. It's these percentages that are going to mean everything. Okay? So all your normal distribution is going to look like this. Okay? There's your mean. Okay? In this case here, it's a 68. This is your 68% of the, 68%. That's just, that is, a coincidence. Okay, 68% of the data is under the first standard deviation. Your mean will not always be 68, and I'll show you this here. Now you'll remember there that 95% of all data will be between the second standard deviations, right? But you can break it all down. 34, okay? 13.5, and this one here is 2.5%, and then they're all broken down into their percentages. And if you add them all up, it adds up to 100%. Okay? Keywords though, normal distribution or bell curved. Okay? Because you'll see those words there on the quiz, and I want you guys to get it. Okay? You'll notice here that these numbers, these are the real numbers from your data set. I don't know, wherever it is, I don't know, the data set that we're talking about. And you'll see here, they've just put these in here. This is your mean. This is your mean plus 1 standard deviation. This is your mean plus 2 standard deviation. These are real numbers. These are the number of bananas people are eating every day. All right? And they will go in there. And they go right in here. All right, so I'll give you a data set. First thing you do, find your mean. Bang. And then you find your standard deviation. All right, let's have a look at this one right here. In a college statistics class, the mean final mark for the exam is typically 68 with a standard deviation of 9. So here, I'm giving you the mean, and I'm giving you the standard deviation. Use the empirical rule and below diagram. I like to do these with a diagram, and you guys can do it however you want, but I find that this bell-shaped diagram there right here, you'll be drawing one of these just in the margins just to help you out. Okay, so here we're going to use the empirical rule and the diagram below to answer some questions. So What did I give you? The mean is 68. Standard deviation is 9. So here we go. There's your bell curve. Bang, 68. I've given that to you in the question. Now your standard deviation is 9. So 68 plus 9, 77. 77 plus 9, 86. 86 plus 9, 95. So you see, there's your first, we're in the positive side. There's your first deviation at 77, second deviation, 86, third deviation at 95%, right? Because we're dealing with statistics class exam marks. On the opposite side, there's your mean, minus 9, minus 9, minus 9. So you'll see there that what we've done now is we've broken this up. And now you can pick this apart like a pie. You can take out a segment and look at it. All right, so now we've got these numbers here. Let's see what we can do. Use the empirical rule, answer the following questions for a statistics class of 200 students. So let's have a look here. I've given you the question and the answer here. So how many students are expected to score between 59 and 77? And for this test, for this quiz, I've kept it pretty simple. Okay? Things are going to be, things will get a little bit more, what's the word I'm looking for? A little bit more in depth there after test 2, because we're going to take this a little bit further. Not too bad. Honestly, it's not. But for this test here, I'm going to kind of keep it kind of, I'm more about understanding. So, how many students are expected to score between 59 and 77? Well, 59 and 77, these are my two borders for my first deviation. So, I got 34% of the students are in here, 34% of the students are in here. So, 68% of my students fall within a mark of 59 and 77. Well, 68% times 200 students, and there we got 136 students have gotten a mark between 59 and 77. How do we do that? It's all based on these percentages. Okay. How many students are expected to pass the exam? Score greater than 50. Well, where's 50 on here? Where is 50? 50 is right here. And it just so happens that it falls on the second standard deviation. So how many students are expected to pass the exam? So you think about this now. I'm looking for all students who got 50 and above. There's no limit. Well, there is a limit because it's 100%. That's all you can get. But I'm just looking at all the students who got 50 and above. Let's count the percentages. Okay. Well, everything above, there's 13.5, 34%, 34%, 35%. So again, we can quickly see that the above diagram, that approximately the top 97.5%. And you can add this, add this, add this, add this, add this, but everything here is 100%. So if you're looking for everything above, you could just go 100% minus 2.35%. A lot easier. You don't have to add. You just take 100% minus everything you're not measuring. Easier. And so we get an answer of 97.5. Okay. Now 97.5 times 200 students, right? Because that's the question is asking how many students. 97.5 times all that is 195 students passed the exam. That's how that one works. What mark would the top 5 students in the class be expected to score? Okay. What mark would the top 5 students? Well, first we need to calculate what percentage of the data 5 students represents. 5% of 200 students is 2.5%. You just find your 2.5% right here, because we're keeping it easy right now. For your quiz, for your test, everything is going to fall on the deviations. Is that how statistics generally works? Never. But here I'm trying to implement some type of process that you can carry stuff into there for test 3. So therefore the top 2.5% are expected to score a mark of 86% or above. That's how that one works. These are a bit of review questions here. Y'all can try these out. Have some fun with them there. There are some more questions. Have a look at questions there in the back of the chapter for sure. And please be careful. There are a lot of things in this chapter that we are not doing. Okay? Please keep it kind of focused on the PowerPoint. Okay? Because we're not doing, there's a theorem and all that. We're not doing it there. There's a lot going on here. So my advice is have a look. Little bit of a recap there. We did percentiles and quartiles. This formula here, okay, we location of the percentile. Okay. Oh yeah, I like this one. Know this one like the back of your hand, or just being able to recall it. Okay. Looking for P10, 10% of the data there. Have a look at that. And then we got into, remember the MAD, which I will not test you on its meaning or its derivatives or never. But in order to do variance, you have to do the MAD. Okay, and that's the difference there from each data point there from the mean. Okay, which is this one right here. A little bit of a self-check. This one here always adds to 0, but you'll notice there for the variance there, we have an extra column there that squares all this to get rid of the negatives. So have a look at all this kind of stuff. That's it for me. And your quiz will open there. Give me a half an hour. I don't know what the dog is, but I'll open up the quiz there just now. It's all ready to go. You guys will have a week to do it. And next week there is no class. There is only test 2. So yeah, get at it. I'll post. I'll see if I can post some more questions there to help you guys, give you guys some more. But other than that, I think you guys are just doing great. Quiz tool will come out soon. And other than that, enjoy your day. Thanks, guys. I am just going to stop recording.